I'm gonna expand all that and say that mu Vn squared plus mu 2 mu gr sine theta must be bigger than 2 mu gr, no, just the same, 2 gr, and I'm going to expand all that, so minus gr sine theta minus root 3 gr of cosine of theta. And now let's rearrange everything in terms of mu Vn squared here, and that would give us mu Vn squared plus, let's say we get the we're just gonna transfer everything to this side, so we have, well, first of all we could wrap everything by gr, so we have gr of 2 mu sine theta minus sine theta, so that goes a plus, and we have minus 2 gr, which is a minus 2. We have a plus root 3 gr, so we have plus root 3 of cosine of theta, and that's all bigger than 0. Now what we're going to do is going to be basically substituting our value for Vn. So now we have a new dilemma. We have, well then, if that inequality must be true, we also know that, well, what is the minimum value for Vn? Well, we could assume in the question that Vn, let's say Vn is the minimum push width. So yeah, let's say Vn must at least be 2gr 1 minus all that. This here is the minimum value for Vn, right? And so we could say then, well, we could plug in this value here into Vn squared, because that is the minimum value for Vn, and when that is the case, well, we can also say that it should be a slightly bigger, but because it's slightly bigger, let's just assume that it's 0. So we could say that, well, if that makes sense and that Vn squared is always bigger than that, we could say when we plug in that value into Vn squared, it must also be true. So let's do that. We could say, plugging that value in, we could eliminate our velocities and say mu times that value here, which is 2 mu gr, and, or before we do that, let's do that first. So let's plug in Vn squared into that first. So we have, and following on from the previous part, we established that our minimum value of V of n would be this value over here, because Vn squared, so yeah, our minimum value for Vn squared would be this value here, because it must be bigger, and that is the boundary we set by saying that the kinetic energy at this point must be greater than the change in potential energy at this point that would occur. And so we could substitute Vn squared by this value into this equation over here. And we're saying that Vn squared is that over here. So we're going to get something like mu bracket of all of that. So I'm going to expand this here. So I'm going to get 2gr minus, it's a gr sine theta and minus root 3 gr cosine theta, close bracket, and we also have this term over here, so we have plus 2 mu gr sine theta, and we know that that's gonna have to be greater than 2gr minus gr sine of theta minus root 3 gr cosine of theta. Now, I'm just going to expand this mu term too. So I'm going to get, this here is going to be 2 mu. I'm going to have a minus mu gr sine theta and minus root 3 mu gr cosine of theta. And now we have just, we have expanded the bracket out. And we can see one similar term, which is minus mu gr sine theta plus mu gr sine theta. So we could say that that is equal to plus mu gr sine theta, and yeah, you could say that that is plus 1 mu gr sine theta. And then I'm gonna substitute this whole value to both sides, and I'm gonna get 2 mu gr minus 2 gr. So when I wrap that, before I do that, I'm gonna divide every time by gr. And we know that gr is always a positive number, so the sign of the inequality does not change. So we're going to say gr there, gr there, gr there, gr there, gr there, and gr there. And that becomes an equation that says 2 mu plus mu sine theta minus root 3 mu cosine of theta is bigger than 2 minus sine theta minus root 3 cosine of theta. That is a much simpler form. And now, I'm gonna, as I said before, I'm gonna subtract this whole value to both sides of the equation, and because, I'm gonna subtract this whole value from both sides of the equation and get 2 mu minus 2, which is 2 of mu minus 1, plus mu sine theta plus sine theta, so plus mu plus 1 of sine theta, and minus root 3 mu cosine theta plus root 3 cosine theta, so minus root 3 of mu, so minus mu plus minus root 3 mu plus 1, and because it's a plus, we are going to have a minus sign, so minus root 3 times mu minus 1 cosine of theta, and that's bigger than 0 because we subtract the same value to the right side of the inequality. And now we get a really interesting property, and we get a really interesting inequality. And because we have two like terms, mu minus 1, what I want to do is divide both sides of the equation by mu minus 1. But then we know that when we divide both sides of the equation by a negative number, we know that the sign changes. And we also know that because mu the table coefficient, so mu, which is a value between 1 and 0, because it's a ratio of how much kinetic energy drops at each collision, it's going to be something like 0.5 or 0.6 or 0.8, 0.9. And so it's always between 0 and 1. And so we can say that, well, if that's true, then mu minus 1 will be between minus 1 and 0, which is a negative number, negative value. And because it's a negative value, we could, when we divide both sides of the equation by the like term, except for this, the 2 like term, mu minus 1, we're gonna have to reverse the inequality sign and get 2 plus mu plus 1 over mu minus 1 sine of theta and minus root 3 of cosine of theta, and it's now not bigger but smaller than 0. Now, I'm just gonna put a rectangle around that because it's really important. And I'll erase all that. You know what the process I took. So I'm gonna erase. Yeah, I'm gonna erase all that. And say, well, is that our solution? But it's not really our solution yet, because that's not yet our solution, because going back to the question itself, the answer that we want is the minimum value that theta must be, which in the form of inequalities must be the case that our answer must be in the form of theta is larger than some expression that would be in terms of mu, because mu is the only variable, or the only variable other than theta that is in this expression. So we will be able to express all of that into this form. Now, how will we do that? What I'm gonna do is say, well, we know that if we have something like say we have something like a sine b plus c cosine of b. We know that when we have that, we could write that in terms of one sine or cosine, but I'm just going to say sine, really doesn't matter. But we know that that can be transformed to the form of big A sine of some b plus some value, like let's say alpha. It really has a random variable, but anyways, we could do that. We could transform this here into one sine function. That's the point. And so we could do the same for that. And what the good thing about doing this is that then we could say when we have 2 plus something like that is smaller than 0, we could minus 2 to both sides and divide both sides by a and get sine of something is smaller. No, sine of something as bigger than something. Yeah, bigger or smaller anyways, but then when we then arc sine both sides, we get b plus alpha is bigger or smaller than something, and so then we arrive at this final conclusion. We will be able to arrive at this final conclusion, and that is what I'm going to do. So, series then, and do the same thing for this over here. Mu plus 1 over mu minus 1 sine of theta minus root 3 of cosine of theta. And I'm just going to leave, there is a 2 plus, but I'm just going to do this here first. This here is, I'm going to simplify this here first into one sine function first. And we're going to say that is equal to, it's a sine of theta plus alpha. Yeah, I like this form. Okay, we're going to do that. A sine of alpha plus theta plus alpha. We're going to make this into, when I expand this here, it is a sine of theta plus a of sine theta cosine alpha, so cosine alpha sine theta plus a times, now, so sine cosine of theta times sine of alpha, so sine of alpha times cosine of theta. We know that that's got to be true. And now what we have to do is just match the coefficients. We know that a cosine alpha, so it should be equal to that, the coefficient of sine theta, and then a sine alpha must be equal to minus root 3, because that is the coefficient of our cosine theta. And one easy way to do this is square both sides. So we have a squared cosine squared of alpha is equal to mu squared plus 2 mu plus 1 over mu squared minus 2 mu plus 1. And we know that a squared sine squared of alpha is equal to 3. And then when we add, the left side together and the right side together, we have a squared cosine alpha plus a squared sine of alpha, which is the same as just a squared, because sine squared alpha plus cosine squared alpha is 1 for any value of alphas. And so we get a squared is equal to 3 plus that. And when I do it, I'm going to do it a bit faster. So because we add 3 to here, when we make I'd say uniform the denominator, we're adding 3 mu minus 6 mu plus 3 to the numerator, which is 4 mu squared plus 2 mu minus 6 mu, so minus 4 mu plus 1 and a plus 3, so plus 4 all over mu squared minus 2 mu plus 1. And that leaves us as a is equal to plus or minus, and wait, is the plus or minus relevant? Is it necessary? Yeah, we do need the plus and minus. So that's going to be plus and minus of, we could wrap that, the numerator by 2, and we get 2 square root of mu squared minus mu plus 1. We get the 2 out. And this, because it's mu minus 1 squared, we're just going to get mu minus 1. But I really it really won't matter if we have the plus or minus sign or not. Not really, because because theta, if theta is, theta is always going to be positive. So I say it for now. I say I'm just going to neglect the plus and minus sign for now, for the purpose of solving this question first. So I'm going to have that expression as a, and we also know that a sine of alpha is minus root 3, and I'm going to use that to figure out what alpha is going to be. So we know a, and we know that sine alpha from that equation is minus root 3 over a, which means that because the fact that sine alpha is a negative value, it means that, oh wait, okay, let's just do this first. So minus root 3 over a would now be, when we plug in a to this over here, we're going to get minus root 3 times the denominator here, and reverse it because we're reversing the sequence when we're dividing, and we get 2 square root of mu squared minus mu plus 1, which is minus reverses the direction, so we have root 3 of 1 minus mu and 2 square root of mu squared minus mu plus 1. And that is our value for sine alpha, which means that alpha therefore is equal to arc sine of that value. That is our value for alpha. And we know a, and then we know alpha. And that means that we could write this equation in a new way. So that equation here would be equal to 2, same, plus, we said that is equal to a sine theta plus alpha. That here is equal to a sine theta plus alpha. And we just figure out what a and alpha should be, which is that and that. So we have plus 2 square root of mu squared minus mu plus 1 over mu minus 1 times the sine of theta plus arc sine of root 3 1 minus mu over 2 mu squared minus mu plus 1. That is going to be smaller than 0. So that and that is basically the same thing, but what's convenient now is that we only have one sine. Here we had sine and cosine, which makes it more complicated, but now we have only one sine, so it's much easier. Although it looks a bit more complicated, it's going to be much easier to reach our conclusion in this form. So now let's do that. Let's erase all that, because now we have a better way to express that equation. And I'm gonna, let's do it. Let's do it here. So what we're gonna do is, first of all, subtract minus 2 to both sides and get that is 0, and that there is minus 2. And we're gonna multiply both sides. I'm gonna divide both sides by this coefficient. That's what I'm going to do. I'm going to divide both sides by both equations, and that gives, well, we first have to figure out whether this here is a positive value or a negative value. We know that square root of anything, square root of something is going to be a positive value unless this here is negative, and we're implying that this here is positive because the square root of anything must be positive if it's not a imaginary, if we're not counting the imaginary values, and we are not, because this here, it's a real phenomenon. It's not going to be about imaginary numbers. So here I'm going to say, well, that is always going to be positive. That here, mu minus 1, again, it's negative. So positive divided by negative is a negative value. And so here I'm going to have our inequality sign reversed. And anything else is just going to be the same as doing the same thing in the equations. We divide this here, so this is going to be cancelled. So sine of theta plus arc sine of all that is going to be bigger than minus 2 divided by that, which is minus 2 times mu minus 1 over 2 square root of all that, which is when we divide both fractions by 2 and then reverse the direction. So 1 minus mu here we have 1 minus mu divided by root square root of mu squared minus mu plus 1. And now now we're just done. And I'm just going to erase this. Now we can write this form into exactly the form as is here. First of all, we're gonna arc sine both sides. So the sine is gonna be gone from here, and there's gonna be an arc sine here. So we have theta plus arc sine of square root of 3 times 1 minus mu over 2 square root of mu squared minus mu plus 1 is bigger than the arc sine of 1 minus mu over square root of mu squared minus mu plus 1. And because that's a plus here, we're going to subtract this whole thing here to both sides and get theta is indeed larger than arc sine of 1 minus mu over mu squared plus minus mu plus 1 minus another arc sine. There's an inner form of root 3 times 1 minus mu over 2 times mu squared minus mu plus 1. And that is the conclusion of our video, because that here is our, it's our equation. It's our inequality that describes what theta should be, that describes what the minimum value for theta should be in terms of mu, which is our table coefficient. And it's really interesting to see that, apart from the mass, it's really interesting to see that theta doesn't vary in terms of neither the gravitational acceleration or the mass of the pencil. You just imagine this not as a mass problem, but now step back from the mass and look at it as just a real life situation. You basically have a table here, and the pencil is rolling. And in figuring out what the minimum angle should be, such that when you give it a little nudge to the pencil rolls indefinitely for an infinite, length. That condition for theta, it doesn't depend on the mass of the pencil. It does not depend on, the gravitational acceleration. It does not depend on the length of the pencil, the side length of one pencil. None of that matters. The only thing that matters is the table coefficient, which is the ratio by which the kinetic energy of the pencil is lost, every time a new edge makes contact with the table. And so it's really interesting. And this equation over here, I'm still not sure whether it's right or wrong. But I have never seen this equation in any other place, and yeah, it's completely derived by myself, but I'm not sure. I'm not sure if it's right. I'm not sure if it's wrong. So if you found any mistakes while I was deriving this inequality, feel free to put a comment down below. Yeah, I think it's really interesting. It's this table coefficient being the only variable that decides this minimum value for theta. It's really interesting. And yeah, to verify whether this equation works in real life or not, I'm going to say what happens if let's say mu is equal to 0.6. So every time the pencil collides with the table, 0.6 times that kinetic energy before the collision is 0.4 of that is lost, because it's 0.6. So every time it makes contact, we multiply 0.6. So what would happen if mu is equal to 0.6? What would that be? Right, so as I said before, I'm gonna now what I'm gonna do is plug in the value of 0.6 into my formula, my inequality formula. Alright, so my inequality formula says theta must be greater than arc sine of 1 minus mu divided by the square root of mu squared minus mu plus 1, bracket closed, and minus subtract the value of arc sine of root 3 times 1 minus mu over 2 square root mu squared minus mu plus 1. So that is my formula. Now I'm going to plug in the value of 0.6. So we have arcsine of 1 minus 0.6, which is 0.4, divided by the square root of 0.6 squared minus 0.6 plus 1, close our bracket, and then subtract the arcsine of root 3 times 1 minus mu, which is 0.4 again, and divide the value of 2 times the square root of 0.6 squared minus 0.6 plus 1. And then we close our bracket. That gives us an answer of 0.068 radians. And now, to visualize this, I'm more familiar with the degrees system, so I'm gonna convert that into degrees, which by dividing by pi and then multiplying by 180, which gives us an answer of 3.899 degrees. And I think 3.899 degrees is quite of a reasonable answer. It's a inclined plane, not really steep, but not that shallow too. It's like, it's a reasonable answer. And even though I'm not sure whether my inequality formula is correct, but I think it's right. By the looks of things, the numerical answer does look promising, and again, as always, thanks for watching. Please follow my future videos, that's my answer to the problem when mu is equal to 0.6. Thank you.